Hello, Matt Davis here with some more homework quiz help. This one is coming from section 5.5. A December 2009 article by the FINRA Investor Education Foundation reported that 54.7% of Americans said that in the last year they had always paid off their credit cards in full. Suppose that we randomly sampled 34 Americans at that time and let X equal the number that had always paid off their credit cards in full during the past year. Calculate the probability that 17 is less than X is less than 22. And approximate your answer using 4 decimal places. So the first thing, in the interest of giving help instead of answers, is we're going to change the question. So we'll make this the probability that 16 is less than X is less than or equal to 19. And we'll go from there. All right, so first of all, we need to recognize the situation. We have a sample of 34 Americans. We're letting X be the number that had done a certain thing. So we're repeating a process 34 times and counting the number of successes there. So this is an NPQ problem, so we'll start off by noting NP and Q. N is our sample size of 34. P is the percentage of Americans that pay off their credit card in full each month, which is given as 54.7%, but we convert that to a decimal, so 0.547. And then Q is 1 minus that, which would be 0.453. After we get that set up, then we have to make sure that we're sorting out what's being asked. Since X is the number of successes, this is a discrete problem, and X can only be a whole number. So if you look at these symbols right here, we have X is greater than 16. That does not include the 16. So that means that we're going to start out with 17. But on the other side, we have less than or equal to 19, so the 19 is included. So we want the numbers X that are between 16 and 19, including 19, but not including 17 because of the difference in the symbols. So, since this is discrete and can only be whole numbers, we're looking at the probability of 17 plus the probability of 18 plus the probability of 19. And we're going to want to add those together. So we'll do that work, but how do you get the probability of 17, 18, or 19? Well, this is an NPQ problem, so to get the probability of 17, you need to do N choose X, which is, in this case, 34 choose 17, times P, which is the 0.547, raised to the number of successes, 17, and then Q, 0.453, raised to the leftovers. So it's a little tricky here, but 34 minus 17 is 17, so you end up getting the same exponent on both. But that's not the rule. The rule is subtract X from N to get your exponent on Q, and in this case, they both just happen to end up being 17. And then we would go to the calculator and see what we get for that. When we're done, we'd want to change this for 18 and 19. And just to show you how we do that here real quick, if you want this to be the probability that X equals 18, you would just change this to an 18, the exponent on P to an 18, and then over for Q, you would have 34 minus 18, that would become a 16. And then, if you want it to be the probability of 19, you would change this to a 19, this to a 19, the exponent on P to a 19, and the exponent on Q becomes 34 minus 19, which is 15. So we can just make small alteration each time to get the new version. I want you to keep that in mind, that each new calculation is a small alteration of the previous one, and we'll take advantage of that on the calculator side of things. So the first thing we're going to do is the P of 17. So 34 choose 17. So first type the 34, then the math button, then the probability option, then the NCR option. So there's our 34 choose, and we want 34 choose 17 times P, which was 547, raised to the 17th, times Q, 0453, also raised to the 17th. So there is our P of 17, 0.1168. Now, instead of starting over for P of 18, I'm going to hit the second button and then enter, and it pulls up my last calculation. And then all those changes I just made with the red pen a minute ago, I can make here on the calculator. We want this to be 34 choose 18, p to the 18th, and q to the 16th. And now we have p of 18, but we did it real quick because we just edited the last one. Second enter, do it again. Now we want 19, so n choose 19, p to the 19th, q to the 34 minus 19, which is 15, and then we get our third one. So we get all three of those kind of quick, and that's important when you're trying to do this formula over and over again. Cut out some of the tediousness by making quick changes to your previous calculation. So now that we've done that, we can come back and start writing down those answers. So for p of 17, we had 0.1168. Then we'll add p of 18, which was 0.1332, plus 0.1335. Add all those together, and you get 0.3855. And that would be our answer for this question. So a few keys. One, really paying attention to these symbols at the beginning. So less than, strictly, means we don't include the 16, so we started at 17. Less than or equal means we did include the 19, so that was part of our list, and then 18's in the middle too, so we got that thrown in there. So that's a key spot where this could go wrong. Another spot is making sure that you take that percentage version of p and convert that to a decimal, otherwise things will go wrong. And then in terms of speeding things up, just noting that p of 17, 18, and 19 are very similar. So if you type p of 17 all in one line on your calculator, you can just edit that and get a quick answer. One final thing I want to show you, and that's a calculator trick where you can get all three of these at once and get the sum quickly as well. So this is optional, but it is a nice little trick to speed things up. So you go into the Stat menu and the Edit menu, and in your list 1, you put the X values you want. So in this case, that's 17, 18, and 19. So L1 now represents the X values we're interested in. So in L2, we want to put a formula that uses those X values. When you want to do a formula for a whole column, you don't start in the first cell, but use the up arrow to highlight where it says L2, and this is where we're going to type our formula. So our formula for a binomial probability calculation is n, which is 34, and then choose, so math, probability, NCR, and then we would put x, but our x values are in list 1, so I'm going to hit second and list 1, so that is my n choose x right there. And then times p, 0.547, raised to the x, but the x's are in L1, so again, second L1, and then times q, 0.453, raised to the n minus x. So because there's a calculation in my exponent, I need parentheses around my exponent. So n minus x, I'm going to do open parentheses, then n, then subtract the x values, which are in L1, and then close those parentheses. So I end up with 34 choose L1, which is 34 choose x, p to the L1, which is p to the x, times q to the 34 minus L1, which is q to the n minus x. When I press enter there, I get all three of the probabilities that we previously calculated one at a time for 17, 18, 19, all at once. And we could do this even if we were doing like 0 through 34, the whole list, we could still get them all at once as long as we typed all the x values into L1. And then a little trick for getting the sum, go over to the first cell of L3, and above the stat key in orange it says list. If you hit second and then list, you get this menu, choose the math option up top, and then we have a sum option, and I can take the sum of L2, and then I'm adding those three probabilities together, and if I round that to 4 decimal places, I get 0.3855, which is the same answer that we had a moment ago. So this calculator trick is optional. You can definitely do it the way we did it the first time on the previous page, but the longer the list of items that you need to calculate the probability for and then add together, the more powerful this calculator trick becomes. All right, I hope this helped you out with whatever you were struggling with on this problem, and good luck to you as you return back to the quiz.